Hello, hi everyone. Welcome to the Student the Brand STB. So here you can see today topic is current carrying conductor placed in the magnetic field. So we are placing the current carrying conductor in the magnetic field. So how it will be, how it will act. So we will discuss now. So you can observe. I am taking this a stand. So you can consider this a stand. I am taking like this, right? So this is supporting stand base, and this is the rod where it is supporting, and here I am considering the aluminum rod. You can consider like this. So here I am taking aluminum rod. So this is aluminum rod. Okay, so here it is supporting. It is connected to one end, another end is connected like this. So that will be placed in the magnetic field. So I am considering positive terminal, negative terminal, switch, current is passing. So current will pass through this one. So positive terminal, negative terminal, and here I am placing the north pole here, and here it is south pole. This is a U-shaped magnet. So U-shaped magnet I place. Okay, like this. So conductor is placed in the U-shaped magnet. So I hope it is clear to you. Just check it once. So I am taking this is north pole, this is south pole. Clear? So current carrying conductor placed in the magnetic field. So current will be passing like this. Current is passing through this one. So now when the current is passing, automatically this conductor will act as a magnet. So that magnet is placed in the magnetic field. So that is north pole and south pole. That is U-shaped magnet. Now if you take one magnet, so north pole and south pole. So one more magnet if you consider, if you place nearby it, so this one magnet, second magnet. If you place second magnet to the near to the first magnet, what happens? Some attraction or repulsion will take place according to the poles. So here if you take north and north, it will be repulsive. If you place south and south, it will be also repulsive. If I place north and south, it will be attractive. If I place south and north, it will be attractive. Okay, fine. So now what happens? So in which direction the force will act on the conductor? In which direction the force will act on the conductor? How we can identify? So by using which rule we can identify? So the force acting on the conductor. So we can use Fleming's left hand rule. We can use Fleming's left hand rule to identify the force acting on the conductor. So that is Fleming's. So you can consider stretch three fingers of thumb finger, index finger and middle finger perpendicular to each other like this. If you stretch perpendicular to each other, so thumb finger represents force, thumb represents thumb represents force, and index finger represents so magnetic field, and center finger or middle finger middle finger represents what is that, current. Okay, so once again you can see thumb represents the force or current or force acting on the conductor or movement of the conductor also we can see, and the index finger represents magnetic field and central finger represents the current direction. So you know here magnetic field already you know, current also you know. So we can identify the force acting on the conductor. Yes or no? We can identify. Suppose I am taking this book, so you can consider this a book. I am taking. So here, suppose one example I will take. Then you can understand. So now you can see here. I am taking this motor diagram. So motor diagram, electric motor. So inside how the circuit diagram is arranged. So it will be, this is north pole and south pole. So current carrying conductor placed in the magnetic field, force will act on it or force experience. So how it will experience, in which direction it will act. So by this example we can clearly understand the force acting on the conductor, in which direction, particularly which direction it will act, we can able to identify. So now we can see. So on the North Pole, if you consider on the North Pole, if you use Fleming's left-hand rule, so you know current direction. So you know the current direction, current is passing. So if you take north and south, east and west, if you consider north and south, east and west, so then the current is passing north to south. Okay, so we can take the middle finger. So that is nothing but here central finger is nothing but current. So thumb is nothing but force. Index finger is nothing but magnetic field. Mother, father, child. So this rule also we can remember. So in that way, that is mother, father, child rule. So now we can consider at the North Pole. So you place the Fleming's left-hand rule. That is middle finger upward direction. Magnetic field, you know, right? Index finger represents the magnetic field. Index finger represents the magnetic field. So now you can place. So this magnetic field. So you can place along the direction. Along the direction you can place. And current is passing upward direction. Then in which direction thumb is showing? Inwards. Inwards. So you can clearly observe. So this is the upward direction. This is along the magnetic field. This thumb. So thumb you can see. Thumb you can see. So which direction thumb is showing? Towards inward direction. Inward direction. So at the North Pole it will be inward. So you can observe clearly. So at the North Pole inward. At the North Pole inward. So here, so central finger upward direction, index finger along the magnetic field direction. So here you can observe. Then thumb finger represents inwards like this, right? So here you can take this book. You can take this book. So you can consider this is the North Pole. This is the North Pole. This you can represent North Pole. This represents South Pole. At this point we will see. At this point we will see. Here you can see at this point. So current is moving upward direction, north to south to north. So magnetic field will be there. So inward direction at the North Pole. So force is acting downward direction. So it should rotate like this. At the South Pole you see current is moving downward direction. Then it will go north to south like this. And index finger same. So you can observe. So current is will be downward direction, index finger along the direction, then thumb showing upward direction. So by this we can understand, by this book we can understand at the North Pole. So at the North Pole the force is acting inward direction, at the South Pole the force is acting upward direction. Then the book will rotate like this. Understood? So then it will be rotating like this. Like this. Clear? Yes. So I hope you understood. So that is current carrying conductor placed in the magnetic field. Then force will experience on it. Then so this is about the, that rule will be used in electric motor. Electric motor. Right? So that is about the Fleming's left hand rule and current carrying conductor placed in the magnetic field. Thank you so much. Like, share and subscribe to my channel to get this type of concepts explanation in further videos. Thank you.